All right, there we go. You do have to wonder if the Ann Arbor folks wonder, like, what happens for like the first 7 or 8 minutes of class. Those things can't be recorded.
I've never seen the recording start sooner than 11:10.
All right, so let's get bigger. Oop, oop.
Yes, you did.
Yeah. V to shut up.
That's so rude. That's really
This is on the recording here. You only get so many questions to the Ann Arbor side as well.
I'm asking for them.
All right. Somebody want to hit the third button down, please? So let's look at the homework assignment here. Here I can. Everybody can read that? Whoa. All right. So I already was helping somebody with this, so I think we have the first couple things. So shut up! So for starters, we're supposed to have a constructor for a lit expression, right? I added this helping somebody in my office. So this was part of what you had to write for your homework. Is a constructor for a lit expression where it's a lambda, takes in a number, and just returns the number. That's what a lit expression is. Then we have a predicate for lit expressions, where a lit expression is a lambda that takes in an expression and it returns whether or not that expression is a number. That's a predicate for it. Everybody cool with that? All right. And now the problem this is trying to solve, just to kind of put this in the context of language stuff, is this right here is a var expression. Now, Scheme doesn't have types, so I just kind of am showing you Java code here, C# code, pick your poison. So we don't have types in Scheme, so we can kind of dump that. But we're creating a variable named A, set it equal to 5, is kind of the real life programming stuff here. This guy would be, well, this is a symbol, so this would be an assignment operator that our language currently does not support. All right, but if we were identifying these guys in the wild, we would say that this is a var expression and this is a lit expression. So if I were to print out that guy, it would have to resolve the value of A first, boiling down to its value, whatever it was. In this case, we presume it was probably a 5. This guy is a lit expression. A lit expression just is. Its value is what it is. Okay? So a 5 is a lit expression. That's an example of a lit expression. And A is an example of a var expression. In var expressions, we need to take one extra step to resolve it. All right, so for our homework today, we were supposed to write call it apply program? Apply program, apply expression. So apply program effectively took an expression and packaged it with a starting environment, right? And you could send it some stuff in your starting environment if you wanted to have your var expressions actually work, because we don't have a way of binding quite yet, but we're getting there. We don't have this ability yet to say this variable is equal to this value. We can't quite do that, but we will be able to do it in a microscope with a lambda expression soon, probably today. Okay, so let's dump this stuff. Microscope. All right, so I'm going to define an apply program. This guy is going to be a lambda that's going to take in a LC expression as a parameter. Who?
You got an R.
Oh, look at that. You almost threw me off there. Bad.
Actually doing his job.
Seriously. It's the hat. He's wearing the hat, the cutie hat. So this guy's going to take a lambda calculus expression, and we're going to go ahead and call apply, what do I call it? Apply expression?
Yes.
Passing it that LC expression, and initially I'm going to go ahead and pass it the empty E and B as a starting environment, although we're going to modify that here in a little bit for testing purposes. Okay, so that's what apply program does. When you start your program, you say, here's my expression, my collection of expressions, and well, eventually we're going to move to a collection of expressions. Right now it's a nested expression awesomeness thingy. All right, and then here's the environment in which I want you to execute it, because we're dealing with environment passing interpreters right now. For this exact second, I'm going to pass it the empty environment, but in a few minutes, I'm going to pass it an environment with some stuff in it, so I can work with it. Okay. In fact, here I'll just move that above there. That way, I can conveniently pass that environment in here in a few minutes. But right now, the starting point would usually be fresh program, fresh environment. Right? Here's your empty environment that you can work with. All right. So now we're supposed to write apply expression. And apply expression is going to be a lambda. It's going to take in an expression, and it's going to take in an environment. All right. Those two things. Now, for right now, our expressions can only handle, you only needed to write the logic for var expressions and lit expressions, right? Okay, but we do have 4 productions for our lambda calculus language right now. We have lit expressions, var expressions, lambda expressions, and app expressions. 4 different kinds that these guys come in. All right, we'll end up writing them all today so I can give you something really impossible for homework. So we'll go ahead and start off with a cond here. And we'll start off by saying if we're dealing with a lit, is it EXP like that? Is that how I wrote it? Lit EXP question mark. So if my expression is one of those guys, what it means to apply, so when I say apply expression, what am I actually saying? What do I expect this function to do? Yeah, like run it, execute it, actually do it. We're no longer representing stuff here. Now we're saying, hey, I've given you all the building blocks to build your fancy schmancy expressions. Now I'm going to give you that function, that expression, with an environment that may or may not have stuff in it, and I want you to now execute it and give me program output. That's what languages do, right? Languages give us a way of talking to the computer, but at the end of the day, we want it to do something. So now we're actually having this guy do something. So apply expression is going to take in the expression we're trying to apply and the environment in which we're applying it, and it does its thing, whatever. Okay, so if I'm looking at a lit expression, I boil down to just that expression, the number in this case. All right, that's what I do for a lit expression. Sorry, I haven't boiled it down yet. There it is. So I'm asking the question, if my expression is a lit expression, then boil down to the expression. Otherwise, if it's a var expression, what do I do? If I have a variable, what do I do with that variable? Go ahead.
We have to see if it's outside the environment or not.
Okay. We could do that. We could do some error checking and have our have a runtime errors and check to see, hey, does this guy actually exist in the environment? And if he does, then I can say, now let's resolve it. If he doesn't, then I can actually go and look it up. We don't actually have to do error checking in our case here. So what would be assuming it exists, what would be the next step? Well, if I am looking at a var expression, what's an example of what EXPR looks like? It looks like either just A or B or D, something like that, right? So those are just variable names. What do I do with a variable name? I think Jack told us last class. Go ahead.
You look it up in your environment.
I resolve it. Yeah, I have to look it up in my environment. And we should have a function for that we wrote.
Apply environment.
Apply env. where I give it the name of the variable and the environment that I want to look it up in. So I'm going to call apply env, and I'm going to pass it my variable and my environment, and this guy should give me the value. Make sense? Okay. Now, let's go ahead and write the fillers for our next things. So we'll go ahead and say lambda expression, expr. All right, so for this guy, we'll just say not implemented. That's what he'll boil down to for right now. All right, because we don't handle lambdas yet. You could have written something and just say, look, I'm not doing any binding, but we'll execute the rest of it if you want to. But just to keep it simple, because I think I gave you some examples that your code should work for. So if I gave it the program just A, it would give me a 3. But I did give you one that was an app expression. So for right now, we'll just kind of omit lambdas, but we'll still handle app expressions. All right, so if it's a lambda, we're not going to do anything with it yet. We'll just say it's not implemented. Future feature, not included in the free version. Pay us $4.99 for ability to bind variables in your useless language. All right, otherwise we have our else. We must be dealing with an app expression. And what did we do with an app expression? Well, we have to call apply expression on the car and the catter. First and the second part of it, right? Now we can decide how we want our output to ultimately look, because really what I want to do is I want to do two things here, right? I want to call apply expression on the first part, and I want to call apply expression on the second part. How do I say two things? If we're doing it in terms of what I've done in class so far, maybe we create a list out of that, where we have our output is kind of a list of outputs. So what I might do is I might say else create a list out of apply expression passing it the car of expr with the environment, and apply expression passing it the catter of expr and the environment. So that's apply expression. That should be the homework. All right, so if we want to test this with our apply program, well, let me get I wanted to keep my sample environment right next to apply program, so it will, actually, just out of curiosity real quick, I just want to test this. I'm going to pass it the env, but I'm not defining the env until afterwards. I want to see if it does it as one pass or two passes. So I'm going to go ahead and give it an environment that has an A, B, and C equals 1, 2, and 3, just as a starting point. And then I'll create a, here I have my nice little expression here, app expression, where I have a var expression A and a lit expression 7. So this should give us a 1, because that's the value of A, and a 7, that's the value of 7. So we'll go ahead and call apply program on my expression. And we're looking to see if we get an error on the env here. Oh, I have Java code written randomly inside my, so it's, that feels like it's on Blaine, I think. Okay, interesting, yeah. So I don't know that I would necessarily recommend this, but it does do this in 2 passes, because I'm using a variable called the env here, but I don't define the env until the very next line. So it becomes a chicken or the egg thing. I'm actually using it before I create it, but it did work. So what that tells me is that the scheme interpreter here is going through all of your code first, collecting all the symbols, then making another pass and actually running it through the interpreter. All right, we lucked out in this. I was experimenting with it real quick, but just instead of relying on that fact, if I'm going to use a variable inside of there just for my testing purposes, I'll just go ahead and do that. Similarly, I could have actually just hard-coded this inside of here if I just wanted to have my sample environment. But I'll define my environment to test with. In fact, here, let's call it the test env, because that's what this guy really is. And that's what I'll pass along there. All right, and then we'll call this guy my test expr. And that's what I'm passing in there. Just a little bit cleaner variable names. And we get the correct output there. If I change my A to a C, I should get a 3, right? Yep, C is associated with the value 3. So now I'll get 3 and 7. All right, so that's the homework. Questions about that?
So then if you get a D within it, it cannot find, so it's just split out.
It's whatever our apply environment does for an unfound variable. This is where Blaine's runtime exception would give us a false. So couldn't resolve the variable. But this is where Blaine's runtime exception would have come into play. If we think about modern languages, they have exceptions in them where it'll scream at you during runtime. So Blaine's interpreter would have said, hey, this variable does not exist, so I'm going to give you an error message, because he actually checked to see if the variable worked. My interpreter assumes perfect programming. Don't use a variable you haven't defined. If it's not in the environment, don't use it. Program will just crash. That's the way God intended. Christian worldview. All right. Pal, you had a question?
I was just gonna double check that we're not doing anything with truth values or strings quite yet.
No, I think we said lit expressions are just numbers.
Okay.
Because I think at the end of class, Austin asked about that specifically. You asked and I answered it, and you still are asking it again?
No, I don't think I.
Yeah. Well, it doesn't matter. Our language right now is a language of numbers.
Okay.
Because I think somebody asked, do we have to support all scheme types? And the answer is no, we don't have to support all scheme types yet. You can. It wouldn't really actually drastically change what we have here, but supporting numbers only is good enough to understand how languages work under the hood. Then we can decide we can invent new types that we want to support. Before long, we're going to be supporting function types, right? Because we're going to want to actually be able to use our app expressions. Okay, so questions about the homework. For those of you that struggle with it, hopefully when you saw the solution here, you realize it was way easier than you thought it was. So understand, languages are not so complex. You just have to force your mind into thinking about them one little tiny step at a time. Instead of thinking, I'm a programmer, here's this monster in between, and then I have a computer that shows me the output, and it's impossible for me to write that, to implement the monster myself. When really that monster is just a whole bunch of little if statements that say, if it's this kind of expression, do this. If it's this kind of expression, do this. It's the old style, you've seen in the movies with the telephone operator. You call in and they just plug it in here and plug it in here, and that connects you to the other person. That's all our interpreter's doing. What are you asking me to do? This is what that does. And if it's a var expression, I have to use my environment. So I'll say, okay, you have a variable here, A. I will ask the environment to give me that guy's value, and then I'll give you the value. That's what that guy does. Okay. So now what we want to do is we want to look at our implementation of a lambda expression. Because what we would like to have happen is we would like to be able to write things like what is it, lambda exp, and right now this guy takes in a list of parameters, right? So we want this guy to take in maybe, let's just start with one parameter, just to keep it simple. So this guy takes in a single parameter. And what he's going to do is he is going to, let's just do some, keep it simple. It's going to say A. But actually what this guy is going to be is a var exp A. So that's my test expression. My test expression is a lambda expression that takes in an A and ultimately has a var expression A. Can I run that directly? What do I expect the output to be there? If that's my expression, what's a lambda? Unnamed function. What do functions need in order to execute? Parameter?
Mm-hmm.
I'm expecting a parameter here, but am I giving it a parameter?
No.
I'm not. So what am I going to do? I need to create an app expression with that guy here and a lit expression, maybe a 7. So an app expression presumes, even though we've been testing it where we just give it any two old lambda calculus expressions for the two list, it presumes the first element is a lambda. It's a function. And the second element is the parameter to that function. So now, if I'm looking at this lambda that takes in a variable called A and ultimately spits out the var expression A, and then my input is a 7, what do we expect the output of this to be for a starting point? Let's jump to the end. What's the output of that function if I were to pass it a 7? 7. Okay, it's a very complex function. Okay. But before I can get to that 7, what must have occurred when I got to this portion of the lambda? In order for me to have this guy boil down to a 7, what did I have to do with this and this?
Associate them?
And how do I associate values with each other? How do I associate name-value pairs
In an environment?
in an environment? So this is a name. This is the value I want it to equal. So I need to extend my environment with that new name-value pair and then do what? Call process, what I call it? Process expression, apply expression. Mm-hmm. Call apply expression on this with my new environment. My now extended environment that now has a binding for A is equal to 7. Does that make sense? So let's write this and you'll see what this looks like. So I had like a not implemented thing somewhere here, right? Right here. All right, so we're looking at lambdas. So what we want to have happen when we have a lambda, and for right now, let's kind of, even though we currently support more than one, let's roll back and just think about our one list of, well, actually, we won't need to do that. Well, yes, we do. We're going to need our, I'm going to assume for right now that we're back to our original definition of a lambda that only takes in exactly one parameter, because we're going to have to rethink our app expression a little bit, because right now our app expression only supports a single second lambda calculus expression. We might need to reimagine that slightly for our language, okay? But we'll get the point across here with the simpler version of this. So if I'm looking at a lambda expression, I know that I have a single parameter for right now. And I need to associate that single parameter with a value. Now, where did that value come from? So now we got to come down here to our else. So I'm going to dump this stuff here. That guy's closed off. If I'm looking at an app expression here, the presumption is the first element is a lambda. The next element, the rest, It'll eventually be the rest. But for right now, the next element is my inputs. Okay? So what I need to do is I need to create a binding for this lambda expression in terms of the parameters. So if I'm in an app expression here, and I assume the first part is a lambda, so I'm going to actually kind of create a let here to allow this to happen. So I'm going to say else let the lambda be the car of expr, and let the, I'll just call it operators, be the cooter of expr. The rest, we want to have it just be the one operator for right now. I said we're going to keep it simple, right? We'll say it's the catter of the expression. All right, so my one operator is the catter of my expression, and my lambda, this is the actually, we're going to call this the operator, and we're going to call this the operand. Okay, so operators get applied to some operands. So this would be like my 7 here. That's my operand. And my operator would be this function, for example. All right, so now I have a little local environment that has these two values in it, operator and operand. I think the book calls them Raider and Rand or something like that. Okay, so now what do? Well, before I can execute this, I need to, well, I know that it is the operator that I'm going to need to apply, right? So I'm going to say I want to apply an expression. What expression? The expression that is my operator. That's the expression I'm applying. But I'm applying it in a new environment. That is a extend env, passing it my operand and passing it my existing environment. All right, so for our app expressions, where we are applying a function to an input, I want to apply that function in this newly extended environment. But now we have a problem. The operand that I'm giving it is the variable name. But what am I missing? I'm missing the value, right? I need the other part. Actually, this isn't the variable name. This is the value. I need the variable name. My variable name will exist where? Inside the operator. We're assuming the operator is our lambda. How do I get the variable name from a lambda? Did we have deconstructors that pulled out pieces? I think I asked this question one other time. I don't think we did. All right, so in order to get that one operator, because extend env takes three things. It takes in a variable name, it takes a variable value, and the environment we're extending. I've only given it 2 things here. I've given it the value. That's my second value. That is what's going to be associated with it. Now, can I necessarily just pass it operand? What does operand look like? Right now it looks like that. What do I do with things that look like that? Is that a value?
No.
Not yet. How do I get the value? How do I juice that guy into the value that he is?
You apply expression.
Call apply expression on him. Good. All right, so we're not even ready for this guy yet. Okay, so really my operand here is going to be apply expression on that guy given the current environment. Now my operand will get its actual value resolved inside the current environment. This now allows me to pass var expressions in as parameters. All right, so whatever the second part of my app expression is, whatever kind of expression that is, for right now, the only two expressions that would make sense is either a lit expression or a var expression, right? I'm passing a parameter to a function. Parameters to functions are values, and our language is a language of numbers. So I'm either giving it a variable name that will ultimately boil down to a number, or I'm giving it a number, a lit expression that is just a number. Okay? So I'm going to call apply expression on that second element of my app expression, passing it the current environment. That is the unextended environment, because I can't extend the environment until I actually have juiced that operand. Because until I've applied that expression and either pulled out the resolved value of the variable name or the literal value. So after this line, operand will hold that resolved value. Then what do? I call apply expression. I give it the operator. This is the function that I'm calling on a new environment. What is that new environment? It's going to be an extend env where I pass it I need to pass it a variable name first. And where does my variable name live? Well, it lives inside of that lambda, right? So that's going to be the car of the cooter. Make sense? So my lambda looks like this. Whatever. I want to get this piece right here. So the cooter of that is this. Well, there's the whole list, right? The car of that is this list. And the car of that is this A. So I want to pass this guy the CAADR of operator along with operand and env. Now this is a little bit ghetto because we are kind of breaking our constructor deconstructor rules here a little bit. So what would make a little bit more sense for us here is for us to come up to our language constructors and for a lambda expression be able to pull out the pieces. So maybe define lambda get params, something like that. And this will be a lambda that takes in a lambda calculus expression. Well, actually, we can just call this guy a lambda exp. That's what he's going to take in as a parameter. And we will return the CAADR of lambda exp. And then while we're at it, we'll go ahead and define a lambda get body. This guy will be a lambda that takes in a lambda expression, and it's going to give us the car of the cooter, the body portion of this. That'll be the body of that guy. Again, we have lambda A, AB, something like that. The car of the cooter. The cooter gives me that list. The cooter gives me that list. The car of that gives me this expression. So carve the critter gets me the body of the lambda. That makes sense? So these are just convenience functions. So I'm going to use lambda get params down here to get me my parameters from my operator. And I'm going to use lambda get body to get me the body of my lambda. That make sense? Hold on, apply expression. No, that's not correct. This guy is still the catter of my full expression, which is the second element of my app expression. Because I'm not getting the body of the lambda here. I'm getting the parameter list of my app expression. All right. So if we wanted to make this guy neat, we'd come up here and say define app exp get rater. Well, it's called get operator. This guy would be a lambda that that took in a app expression, and he returned the car of that app expression. Define app exp get operand. This guy would be a lambda that takes in an app expression, and he returns the catter of that app expression. That. All right, so this is just a convenience thing that says if I have an app expression and I want to get the operand portion of that app expression, I can just call a function that says extract the operand portion of that app expression. Under the hood, it's still a catter. All right, but instead of us using a catter directly down here, we would say for my operand, I want to apply expression on app expression get operand for my expression. And for my operator, instead of car, I would say app expression get operator expression. So that would extract the operator from an app expression. This would extract the operand from an app expression. We will then apply expression on that operand in the current environment, giving us a, let's call it a resolved operand. In fact, we can even call it that, resolved operand. I like that. So then finally, we're going to apply an expression. What expression? Our operator. All right, which should be a lambda. And then we're going, in what environment are we applying it? We're applying it inside of the extend env of our get params from our operator. All right, so this will get us our parameter list. Actually, for right now, it's just going to get us the one parameter. Your homework is going to be to extend this, along with our resolved operand in this new environment. Well, extending the old environment. So this will produce us the new environment with that extra name value pair added in. That make sense? Mm-hmm. All right, so that's what we do for the else. So now going back up to the lambda, if I have a lambda expression, what I need to do is I need to apply expression on the lambda get body of expression. That's the expression that is the body of the lambda, along with the current environment. I've presumably already associated the name value pair. All right, so there's my apply expression that now supports lambdas with exactly one parameter, and an app expression that presumes we are applying a single operator or a single operand to a lambda that takes a single parameter. So now when we run this on this guy here, here's my app expression, whose first element is a lambda expression that takes a single parameter and boils down to a var expression. The second parameter of my app expression is the lit expression. As part of the app expression, we will create a binding between an A and a 7, and we will execute the body of that lambda here. In the, actually we can actually do that. Yeah, I'm going to pass the whole thing in. So we're going to execute this entire expression here in this newly extended environment, which now has an A is equal to 7 in it. And this should give us, so I should now be able to change this guy to empty env. All right, because I'm giving it an empty env. It's going to come in. It's going to be an app expression. The app expression is going to associate the A and 7 in this extended environment and then execute. So it's going to apply expression. This guy here in this newly extended environment now has an A is equal to 7 in it.
Issue in line 154.
Issue line 1.
Misspelling.
Which were? 154?
Yeah. Lit expression beats a P-non.
Looks like that. All right. Found one extra part. So I'm applying an expression. I haven't closed my let correctly, apparently. So there's my let. There's my else. There's my cond. There. Oh, I'm missing the end of my. So that ends my local environment. So I had one extra guy here. I need to give it the single quote there. So you didn't catch all of your errors there, Blaine. And there's my 7. So in this case, I'm actually binding a 7 to a parameter A and then executing the body of the lambda ultimately in that new extended environment. Make sense? So go back through, understand how this code works. I'll give you this entire thing as a starting point. For your homework, make your lambdas work for 0 or more parameters. They still only need to work for the body of a lambda doesn't have to be a lambda. It could be an app expression, which then imply make it work for 0 or more parameters where the body is either a lit or a var expression. That'll be fair enough.
Do you have a test case?
Yeah, I'll put test cases up. Well, here, I'll just put it in here.
Did you change the definition of app expression in this case?
Yes, that's part of the homework. Yep. The homework will be app expression right now assumes a single parameter. Now it's going to assume 0 or more parameters. So now I might have var AB and then the output being, that's going to be kind of stupid here, but
So would that apply to A?
something like that. So here's a lambda AB where a 7 is coming in for A, an 8 is coming in for B, and we're executing the body here as either a var or a lit expression.
I have a question.
So our bodies aren't overly interesting yet, but our number of bindings increase. Yeah.
I thought app expression only take 2 lambda calculus. Is that count as 3?
Just what count as 3?
So app expression only take 2 lambda
It
calculus.
used to.
Also now we modify
Now
it?
we're changing the definition.
Yeah.
That was why we
App expression now takes a function, a lambda calculus expression, but we're presuming that's a function, and a parameter list. Instead of 1 lambda calculus expression, here's 2. If I wanted to take 30 inputs, presuming this lambda took 30 inputs, I would have to pass it 30 inputs over here.
So then the second lambda calculus will be a list.
Correct. But an app expression, now the definition of app expression is now a lambda calculus expression. It's a list containing a lambda calculus expression followed by 0 or more lambda calculus expressions. So if we update our slide here, app expression is now that guy. Put the little asterisk there. 0 or more lambda calculus expressions. This guy's a lambda, this first part. The second part is the parameters being passed into that
So
lambda.
then would that be like when you pass it in, would it be like a list though?
You have to figure that out. It's actually really easy. Write it down on paper, you'll see how easy it is. You don't have to invent anything crazy. All right, I'll put this homework up. I'll see everybody on Friday.